Welcome dear students in the class. Today we will discuss with you the topic tangent and normal in polar coordinate system. As you have already studied the tangent and normal in Cartesian system in the 12th classes. So first we introduce polar coordinate system. In polar coordinate system, there is a fixed point O which is called pole and a straight line OX which is called initial line or theta is equal to 0 line. And coordinate of any point P in polar coordinate system is represented by r theta, where P is any point in polar coordinate system, where r is the length of OP, means join the point P with pole O. This line segment OP, r is the length of line segment OP, and theta is the angle between OP and the initial line in the positive direction or in the direction anti-clockwise direction. This is theta. So in polar coordinate system, a point is represented by r theta, where r is the OP, length of OP. OP is called radius vector. OP or r is OP is called radius vector, and this theta angle is the angle between OP and the initial line, and this theta is called vector. This is the introduction of polar coordinates. Now a very important article today I will discuss you with angle between radius vector and tangent. Angle between radius vector and tangent. This is denoted by phi. The notation phi is this, phi. Now suppose that there is any polar curve is given. Take a point P, r theta, and a point Q in the neighborhood of P, whose coordinates are r plus delta r and theta plus delta theta. Clearly join P with O, OP. It is radius vector and its length is r, and the angle between OP and this initial line is theta. Join Q with O, OQ is r plus delta r, and the angle between OQ and the initial line is theta plus delta theta. So clearly the angle QOP is delta theta. Draw the tangent at the point P which cuts the initial line. Suppose which cuts the initial line at A. So the angle between tangent and the angle which the tangent makes with the initial line is always denoted by psi. And increasing the radius vector OP and draw a perpendicular from Q on OP is QM. So three notations you have already cleared. Theta is the vectorial angle, means theta is the angle between radius vector and the initial line. Angle psi, these notations are fixed throughout the study. The angle psi is the angle which the tangent makes at any point P makes with the initial line, psi. And the angle between radius vector OP and the tangent is is denoted by phi, which we have to find out. So phi is the angle between OP and the tangent PA or PT. Now clearly, when the point Q tends to P, when the point Q tends to P, means delta theta is decreasing, so delta theta is tending to 0. And the chord means the line joining the point P and Q, chord PQ, tends to the tangent PT. In the case, listen again, in the case when the point Q tends to P, angle delta theta tends to 0 and the chord PQ tends to the tangent PT. Clearly, and when QP tends to the tangent PT, means the angle QPM tends to phi. Angle QPM tends to phi. This is the basic geometry which you must understand, otherwise this article will not be clear to all of you. Clearly, in the limiting case, when Q tends to P, means delta theta is tending to 0, means chord PQ is tending to the tangent PT, means the angle QPM tends to phi. So, clearly, phi, we can write phi is equal to, the limiting case means limited delta theta tends to 0, angle QPM, taking the tan of both the sides. So tan phi is equal to limit delta theta tends to 0, tan angle QPM. It is equal to limit delta theta tends to 0, QM upon PM. Tan means perpendicular upon base, means QM upon PM. And what is QM? QM is R plus delta R sine delta theta. So tan phi is equal to limit delta theta tends to 0, R plus delta R sine delta theta upon R plus delta R cos delta theta minus R. And since delta theta is very small quantity, so expand sine delta theta and cos delta theta in their expansion terms, means cos delta theta is equal to 1 minus delta theta square upon factorial 2 plus delta theta per power 4 upon factorial 4 dot and sin delta theta is equal to delta theta minus delta theta cube upon factorial 3 plus dot. Since delta theta is very small quantity, it is negligible, and in the present case delta theta is tending to 0, so neglecting the higher powers of delta theta, we get tan phi is equal to r d theta dr. We find this article that tan phi is equal to r d theta dr. It will also, all of you will remember, we occasionally use this formula throughout the chapter. So what we find, tan phi is equal to r d theta dr, or cot phi is equal to 1 upon r dr d theta. Clear? Angle between two curves. If two curves are intersecting at P, the angle between two curves is defined by the angle between the tangents of two curves at the point of intersection P. Okay, these things are clear. So this is very important article. What? Phi is the angle between radius vector and tangent, and we have find there that tan phi is equal to r d theta d. Now we will tell you two important things: polar subtangents and polar subnormals. Polar subtangents and polar subnormals and their lengths. Clearly see here. Suppose O is a pole, OX is initial line, and any pole curve is given, polar curve. Let P is any point on this polar curve whose coordinates are r and theta. Join the point P with O. Clearly, P angle POX is equal to theta, vectorial angle. And draw the tangent at P and draw a normal at the point P. Also draw a line perpendicular to the radius vector OP from the pole O. The tangent cut this line at T and normal cut this line at N. Clearly, the OT is called polar subtangent, and the portion ON is called polar subnormal. Clear? The PT is called the length of polar subtangent, and the PN is called the length of polar subnormal. Clear? The line segment OT is polar subtangent. The line segment ON is polar subnormal. And the angle PON is 90, or in other words we say that angle POT is 90. So these are right angles. So PON and POT are right angles triangle. Now we find that clearly here from the figure. The polar subtangent is OT, and it is find from the right angle triangle OPT that OT upon R, where R is the length of OP. OT upon R is equal to tan phi. It means OT is equal to R tan phi, and we know that we have find just before that tan phi is equal to r d theta dr. So put the value of tan phi. OT is equal to r into r d theta dr is equal to r square d theta dr. So clear, you have find polar subtangent OT is equal to r square d theta dr. This is one part. Another part we will find ON. What? Polar subtangent is ON. Now in a right angle triangle OPN, ON upon R is equal to cot phi. So ON is equal to R cot phi, and cot phi means 1 upon tan phi, and you know that tan phi is equal to r d theta dr. Putting this value, ON is equal to r upon r d theta dr. So r cancel and it comes out to be dr d theta. So you have find out polar subnormal ON is equal to dr d theta. Now we will find the length of polar subtangent, which is PT. Clearly, in the right angle triangle POT, PT upon R is equal to sec phi. PT upon R means hypotenuse upon base is equal to sec phi. So PT is equal to R sec phi, and put the value of sec phi means it is equal to R under root 1 plus tan square phi, and put the value of tan phi is equal to R d theta dr. So it comes out PT is equal to R under root 1 plus R d theta dr का whole square, means PT comes out, PT is equal to R square root 1 plus R square d theta dr का whole square. This is PT, and it is the length of polar subtangent. Clear? Now we will find out the length of polar subnormal. Here you see that Pn is the length of polar subnormal. So we will find out Pn. In the right angle triangle PON, we see that Pn upon R is equal to cosec phi, means hypotenuse upon R means hypotenuse upon perpendicular is equal to cosec phi. So Pn is equal to R cosec phi, and it is equal to R under root 1 plus cot square phi, and it is equal to R under root 1 plus 1 upon tan square phi. Putting the value of tan phi is equal to R d theta dr, it is equal to R under root 1 plus 1 upon R square d theta dr का whole square, and it comes out under root R square plus dr d theta का whole square. So what is the length of the polar subnormal? Length of polar subnormal is Pn, and it comes out under root R square plus dr d theta का whole square. So four things are clear. OT is polar subtangent, and it is equal to R square d theta dr. ON is polar subnormal, and it comes out dr d theta. PT is length of polar subtangent, and it comes out R under root 1 plus R square d theta dr का whole square. And last, Pn is length of polar subnormal, and it comes out R square root R square plus dr d theta का whole square. So prepare these articles very seriously, and we will meet in next lecture. Thank you very much.